Hi, I am Sanjay Patel. Today we are going to understand an interesting thing about spheres, and that is known as orthogonal spheres. One can surprise that how spheres can be perpendicular or orthogonal to each other. But we are defining mathematically the meaning of orthogonal spheres. But before that, let us recall some basic things from your higher secondary course. The first thing is the definition of angle between two non-zero vectors. Suppose one vector is say x bar and another vector is say y bar, and angle between them is theta, then we know that theta is given by cos inverse of x bar dot y bar upon mod of x bar into mod of y bar. Okay, and these two these two vectors are perpendicular, then this theta is pi by 2. So in this case, if x bar is like this and y bar is like this, and then this theta is pi by 2, this is pi by 2 in that case, and we'll get cos inverse of x bar dot y bar upon mod of x bar into mod of y bar, and that gives you x bar dot y bar is equal to 0, because taking cos on this side, cos pi by 2 is 0, so we'll get x dot y equal to 0. So if two vectors are orthogonal, okay, then the dot product is 0. So that follows from this simple definition of the angle between two vectors. Okay, you also know from your higher secondary that how to find angle between two intersecting planes or angle between two planes. So let me take two different planes, say one plane is like this, and I'm taking another plane. What I want to do is, sorry, not this way. I want to take another plane like this. So these two planes are intersecting planes. Okay. So how to find the angle between, they are intersecting. You know, if two planes intersect each other, then their intersection is a straight line like this. Okay, and this is one plane, this is another plane. Okay, and the angle between the two planes is defined as the angle between the normal vectors of the plane. You know, the vector equation of plane is given by r bar dot n bar is equal to d. So I am taking r bar dot n1 bar is equal to d1, equation of this plane, and for pi 2 second plane, the equation is r bar dot n2 bar is equal to d2. So this n1 bar and n2 bar are the two, say, normal vectors of these two planes. Okay, so this is another vector which is perpendicular to this plane. So this is n2 bar, and the angle between these two vectors, this is n1 bar and n2 bar, is called the angle between say the two planes. So angle between two planes, let me write, so angle between the two planes pi 1 and pi 2 is given by, say, cos inverse n1 bar dot n2 bar upon mod of n1 bar into mod of n2 bar. Okay. The same concept of angle between two planes we use to define the angle between two spheres. So let me write down first definition of angle between two intersecting spheres. Okay. If two spheres, say S1 and S2 intersect each other, then the angle between the two spheres S1 and S2 is defined as the angle between the two tangent planes, angle between the two tangent planes of S1 and S2 drawn at any point of intersection of two spheres, any point of intersection of the two spheres. So what is the meaning of this definition? If we have two spheres, both are intersecting, this is one sphere, and let me take another sphere. Both are intersecting each other, okay, and at any point of intersection, we know the intersection is a circle. So this is a circle of intersection. Let me use the yes. So this is the circle of intersection of the two spheres. It's not coming proper. Yes. Let me move this sphere. Okay. So the two spheres intersect in a circle. Okay. So if you take any point here, say for example this point in the intersection, then I can draw two tangent planes, one on this sphere and other on the first sphere, like this. I can draw two tangent planes, and we have normal vectors for both the tangent planes. This is a normal vector of this plane, and this is normal vector of this plane. So this is n1 bar and this is n2 bar. This is s1, this is s2. This is the tangent plane of the first sphere, this is the tangent plane of the second sphere, and this is a common point of intersection. So the angle between these two, n1 bar and n2 bar, that is angle between the two intersecting plane, is known as the angle between the two intersecting spheres. Okay. So in short, angle between two intersecting spheres is nothing but by taking any point in the intersection Z, that is a circle, if you draw tangent planes to that point, to the sphere, and find the angle between these two tangent planes, then that angle is called the angle between the two spheres. And further, if this angle between the tangent planes is 90, that is pi by 2, then the two spheres are said to be orthogonal spheres. So this leads to definition of the concept of orthogonal spheres. So I am writing definition of orthogonal spheres. Okay, it is very straightforward. Now, if the angle between two intersecting spheres, now you know what is the meaning of angle between two intersecting spheres, is pi by 2, then the two spheres are said to be orthogonal spheres. Okay, or we can also say that they are said to intersect orthogonally. So two spheres are said to intersect orthogonally if the angle between the two spheres is pi by 2. Our main aim and the last topic of this chapter is to derive the condition that two spheres are orthogonal or not. So in this regard, we have a very, very important theorem about orthogonal spheres. So let us write down the statement. Obtain the condition that two spheres are the two intersecting spheres, let me write that way, or directly, two spheres S1, say x square plus y square plus z square. I am writing in a general form 2u1x plus 2v1y plus 2w1z plus d1 equal to 0, and S2, which is again replacing u1 u2 or u1 v1 w1 by u2 v2 w2. This is the equation of the second sphere. Obtain the condition that the two spheres S1 and S2 intersect each other orthogonally. Okay. Or one can also say that obtain the necessary and sufficient condition for two spheres to be orthogonal. Okay. So let us prove this. Remember, if we have two spheres intersecting each other orthogonally, then you will get one interesting thing about this is one sphere, this is another sphere, they are intersecting spheres, okay, and if this is the center of the first sphere This is S1 and this is S2. This is center of the second sphere, say C2. And these are all common points of intersection. Say if I draw like this, and this is circle of intersection. Now if I take any point on this intersecting circle or on this spheres S1, S2 which is a common point, say here, if I take a point P and join the point P with the two centers, then this C1P, let me draw it properly. If I join this C1P and let me use that line. So if I join this, here, and if I take another line and make this thing radius, okay, good. So if two spheres are intersecting each other, then C1P and C2P are the radius of S1 and S2 respectively. Now if we draw tangent planes here and here for S1 and S2, then tangent plane to this sphere and tangent plane to this sphere, like this. Then remember that this C1P and C2P, they are the radii drawn from the point of contact, which is common to both the sphere, that is P. And therefore, the radius, which is C1P of the first tangent plane, it is in the direction of normal of the tangent plane. And C2P is the radius for the second sphere is in the direction of normal of the second tangent plane at the same point. So if these two tangent planes are perpendicular, that means the normal vectors of these two planes are perpendicular, then this angle is say 90 degree. That is, this angle is pi by 2. And therefore, this triangle C1, C2, P becomes a right angle triangle. This is possible when the two spheres are intersecting each other orthogonally. So let us start this way. Suppose two spheres, suppose the two spheres, remember this is an important result, two spheres S1 and S2 intersect each other and P is any point of intersection. Okay. If C1, say minus U1 and say minus W1, and C2, that is minus U2, minus V2 and minus W2 are the centers of S1 and S2, respectively, then C1P and C2P will be the radii drawn from the point of contact, the point of contact say P of the two spheres okay, and let me so C1P and C2P are the radii drawn from the point of contact of the two spheres, and we have discussed that if two spheres are orthogonal, let me write this way, that now S1 and S2 are orthogonal spheres, or say intersecting orthogonal spheres, if and only if angle between the two spheres is pi by 2, and if angle between the two spheres is pi by 2, and therefore the angle between the normals of the tangent planes of the two spheres is also pi by 2. Okay, and if this angle is pi by 2, because we know that the normals are nothing, these normal vectors are nothing but the same as in the direction of the radius C1P and C2B. So if the angle between the normals of the tangent planes is pi by 2, then we have C1P is perpendicular to C2P, and this is true if and only if the triangle C1P C2 is right angled triangle, and if C1P C2 is right angle triangle, then it must satisfy the Pythagoras theorem. So this is true if and only if C1 C2 square is equal to C1P square plus C2P square. Okay, we know what is C1 C2. They are the centers of the spheres which we have written earlier. C1 is minus U minus V1 minus W1, and C2 is minus U2 minus V2 and minus W2. So distance between these two centers, I can write, let me explain here. This C1 center is minus U1 minus V1 and minus W1, and the center C2 is minus U2 minus V2 and minus W2. Okay, and this is the radius R1 and this is the radius R2. That is C1P is R1 and C2P is R2. But what is R1? R1, you know, by our formula of the radius is U1 square plus V1 square plus W1 square minus D1. And same way R2 we can write as U2 square plus V2 square plus W2 square minus D2. So remember this, what is the value of C1P and C2P. We are going to substitute all this in this step. C1 C2 square is the distance, and that can be written using distance formula between the two centers C1 and C2. So I am writing directly, which is very simple, U1 minus U2 square plus V1 minus V2 square plus W1 minus W2 square is equal to R1 square plus R2 square. Okay, this is true if and only if this as it is, U1 minus U2 square plus V1 minus V2 square plus W1 minus W2 square is equal to, now I am writing that formula of this R1 square and R2 square, that is U1 square plus V1 square plus W1 square minus D1 plus R2 square means U2 square plus V2 square plus W2 square minus D2. So if you simplify this, this is A minus B whole square. So U1 square minus 2U1 U2 plus U2 square. This is V1 square minus 2V1 V2 plus V2 square, and so on. So all U1 square, U2 square, V1 square, V2 square will be cancelled with this, all these terms. So what is left finally is only the middle terms here, minus 2U1 U2 minus 2V1 V2 minus 2W1 W2 is equal to minus D1 and minus D2. Only this much will be left. Everything else will be cancelled. So that is nothing but, if you divide by minus 2 both the sides, what you will get is U1 U2 plus V1 V2 plus W1 W2, okay, is equal to D1 plus D2 by 2. So which is the required condition that the two spheres are intersecting orthogonally. So what you need to know is only the values of these constants U1, V1, U2, V2, etc. And that can be obtained from the given equation of the spheres. And you can verify very easily that the two spheres are orthogonal spheres. So this is the required condition for orthogonality, for orthogonal spheres. Okay. Finally, let us solve say one or two examples. So first example, determine whether the two spheres which are say given by this this equations, S1 is x square plus y square plus z square, then plus 2x plus 4y plus 6z minus 11 equal to 0, and second sphere S2 is x square plus y square plus z square, then minus 3x just it is minus 3x and minus 5y plus 11z plus 31 equal to 0 are orthogonal spheres, or not. So it is very simple. What you have to do is just find the values of the constants. So here from S1 we have say U1 is equal to what? 1, V1. Just you have to divide this by 2. 2U is equal to 2 means U is equal to 1. Then V1 is equal to 2. W1 is equal to say 3. D1 is equal to minus 11. And for S2, for the sphere S2, the constants U2 is minus 3 by 2, V2 is minus 5 by 2. We don't have to change the sign here because we are not finding the centers. We are finding simply the constants. W2 is equal to 11 by 2 and D2 is equal to 31. Now the condition that S1 and S2 are orthogonal, now the spheres S1 and S2 are orthogonal spheres if and only if U1 U2 plus V1 V2 plus W1 W2 is equal to D1 plus D2 by 2. This condition we have derived just now. So just we have to find the LHS and RHS of this condition and see whether they are equal or not. All the numbers are given here. So let me find the LHS first. So LHS, that is U1 U2 plus V1 V2 plus W1 W2 is equal to, what is U1 and U2? It is written here. So it is 1 into minus 3 by 2, okay, plus V1 V2, that is 2 into minus 5 by 2 plus W1 W2, that is 3 into 11 by 2. So what you will get is minus 3 by 2. Then let me write this as minus 10 by 2 only plus 33 by 2, so that all denominators are same and I can simplify easily. So 2 in the denominator, it's a common denominator. 10 minus 3 is minus 13, and minus 13 plus 30 is minus 10 minus 13 plus 33 is minus 20. Minus 20 by 2, so it is minus 10, I think. Yes. Okay. And what about the RHS? RHS is simply D1 plus D2 by 2. The D1 and D2, let me check, what is it? Minus 11 and 13. It is minus 11 plus 31 upon 2. This is plus, yes, 33 minus 13 is plus 20, so it is 10. And here 31 minus this is also 20 by 2, so we get 10. And therefore the conclusion is LHS is equal to RHS. And therefore the two spheres are orthogonal to each other. S1 is perpendicular to S2. Okay. And finally, let me take one simple example to find the angle between two intersecting spheres. So find the angle between find the angle between the two spheres given by S1 is x square plus y square plus z square minus 2x plus 4y minus 6z plus 12 equal to 0, and S2, that is x square plus y square plus z square minus 4x plus 4y minus 4z plus 10 equal to 0. Okay, fine. So we want to find the angle between these two intersecting spheres. We know how the angle between two intersecting spheres is defined. If you have two spheres, one is like this. Okay, let me suppose one sphere is like this, and another sphere, say it's like this. They are intersecting each other. Just a minute. The two spheres are intersecting each other, and we want to find the angle between these two. So if C1 is the center of the first sphere, C2 is the center of the second sphere, and P is a common point, then the angle between them is nothing but the angle between the two radius, because we know that the radius is always perpendicular to the tangent plane at the sphere, at the point of contact. So yes, so we want to find this angle. This angle is, say theta. So it is clear that this angle is the angle between these two radius, and to find the angle, what I will do is I will be using this triangle. Let us join this C1 C2, okay, and I will be using that cosine formula to find the angle between the two sides of a triangle. So in triangle C1P C2, we have cos theta is equal to C1P square plus C2P square minus C1 C2 upon 2 times C1P into C2P. You know that cosine rule. If we have a triangle ABC, okay, the side opposite to angle A we call small a, the side opposite to angle B we call small b, and this is small c. So the cos A formula is the cosine of A is b square plus c square minus the opposite side square a square upon 2 times b into c, 2 times the product of the two adjacent side. So I am using that idea. Here C1P C2P is the radius of the two spheres, and C1 C2 is the distance between the two spheres. So let us find the centers and the radius from the given equations. So here the center C1 is minus U1 minus E1 minus W1. From the first equation of the sphere, divide the coefficients of x, y, z by 2 and change the sign. So that is minus 2 by 2, that is plus minus 1, and change the sign 1. So then minus 2 and plus 3. Okay, and d1 is 12 there. For the second sphere C2 is equal to these coefficients minus 4, minus plus 4 and minus 4. That will give you 2, minus 2 and 2, and d2 is equal to 10. Using this we can find the radius. So the radius C1P, that is R1, is equal to square root of, we know, U1 square plus V1 square plus W1 square minus D1. So that gives us U1 square, that is this is your U1 V1 W1, U1 V1 W1, say minus U1, doesn't make any difference because that is a square. So 1 square plus 2 square is 4 plus 3 square, that is 9, minus D, that is 12. So that gives you 13 plus 1, 14 minus 12. So it is root 2. Yes, 2. Okay. And similarly, C2P, that is the radius of the second sphere R2, is square root of this U2 square plus V2 square, that is minus U2, this is minus V2, and this is minus W2. So what I will get here is 4 plus 4 plus 4 minus 10. So 12 minus 10 is again root 2. So C2P, second radius, is also root 2. Radius of both the spheres are same. Further, I want the distance C1, C2, the distance between these 2 points. So let me write the distance. Also, C1, C2, the distance between this is given by 1 minus 2 square plus minus 2 plus 2 square plus 3 minus 2 square. That is square root of 1 plus 0 plus 1. So it is root 2 again. So luckily we are getting all values root 2. Fine. So now I can use that formula to find the angle, this formula. So let me call this as star. So from star, C1p square plus C2p square minus C1 C2. So from star, we get cos theta is equal to C1p. All radius and all values are root 2 only. So C1p square plus C2p square minus C1 C2 square, that is root 2 square, upon 2 times C1p into C2p. Just I am putting the values of all the numbers in this star, C1p, C2p, C1, C2, everywhere. So what I will get finally as cos theta as cos theta is equal to say 2 upon 2 into 2, that is 4. Okay, this will be cancelled, and root 2 into root 2 is 2, 2 to the 4, so we'll get 2 upon 4 means 1 by 2, and this implies theta is equal to pi by 3. So the angle between two intersecting spheres in this example is pi by 3. So this angle we have found as pi by 3. Okay. So this completes all the topics of the chapter sphere. Now we can practice some problems to have more understanding of this chapter sphere.